Hello students and parents, welcome to Concept Clarity Tutorials, and today we are going to talk about acceleration. So we have seen about speed, we have talked about average speed, instantaneous speed, we have also looked at velocity, average velocity, instantaneous velocity, we have seen the formulas of all this, and now we are going to talk about acceleration. We know that if an object is moving, it can either speed up or it can slow down. This process of speeding up or slowing down, this process of speeding up or slowing down is called acceleration. So let us define acceleration now as per the textbook. Okay, I'll clear this definition. Acceleration is defined as acceleration is the rate of change in velocity, right? So we can define average acceleration, A average, as the change in velocity by the change in time. So that is equal to the final velocity minus initial velocity divided by time final minus time initial. This will give you the average acceleration. Now what is instantaneous acceleration? We know when you say instantaneous means at that particular instant, at that particular time. So A instant is given as change in velocity, change in velocity by change in time, provided t tends to 0. This is also defined as the derivative of velocity by time. These are the two equations that you need to remember as part of acceleration. So now we know we have the formula of velocity. Velocity is change in displacement by change in time. And acceleration is defined as the change in velocity by change in time. So we can now rewrite acceleration as derivative of velocity, which is given as dx by dt. So hence we can write acceleration is a double derivative of displacement with respect to time. Hope till here this is clear. Acceleration is the rate of change in velocity, and these are the three equations which you need to remember. We know average acceleration, change in velocity, final and initial. Instantaneous acceleration is at that particular time, at that instant, when you shrink the time period is shrinked such that it tends very close to 0. So I'll clear this. We'll move to the next part of acceleration. Change in direction change in direction of velocity change in direction of velocity without, this is one very important concept, without change means without change means either without slowing down or speeding up. That means here only direction has changed. Only direction has changed, but the velocity has not changed. Velocity has not changed, right? That means there is no slowing up, neither speeding up of the particle. So in this particular case, will there be acceleration? In this case, is this also called acceleration? Only the direction of velocity has changed. We saw that acceleration is change in velocity by change in time. Here there is no change in velocity because there is no speeding up neither slowing down. There is no change in velocity, but the direction has changed. The direction of this object, velocity is constant, but the direction has changed. So even when there is a change in direction of the velocity without change in the magnitude of the velocity, acceleration is still there. Acceleration is defined. Now we know that acceleration has magnitude and it has direction as well, right? Because change in velocity is defined as a change in position, which is a vector quantity, and this is a scalar. So it's obvious case that acceleration is also vector quantity. And the unit is velocity is meter per second and time is second. So acceleration is defined as meter per second square. So if you have noted down this, I will clear this out. We'll go to the next aspect of acceleration itself. We'll see more points about acceleration. This point is very important, that a change in velocity, that there is no change in velocity. Even when there is no change in velocity, but the direction is changing, then also there is a change in acceleration. Acceleration exists when there is a change in direction of velocity. So next part. Does now acceleration from a common reference, if I have a common reference, acceleration, if I go in the positive direction, then acceleration is supposed to be positive. That is positive acceleration. If it is on the left side, if it is in the negative direction, then it's called a negative acceleration. Now, does negative acceleration mean slowing down? No. Negative acceleration doesn't mean slowing down. Neither does positive acceleration mean speeding up. This only indicates the direction of the object. Negative only indicates the direction of the object. Even if the object moves on the left, it could speed up, right? There could be speed involved. It is speeding up in the negative direction. So here acceleration will be negative. Similarly, the object could be slowing down. It could be slowing down in the positive direction. So it's supposed to have positive acceleration. I hope this aspect of the concept is clear enough. If I move in the negative direction, it is negative acceleration. If I move in the positive direction, it is positive acceleration. Negative acceleration does not imply it is retardation. Neither does positive acceleration imply it is acceleration. I mean, it is speeding up, right? I could move in the positive direction. I could move in the positive side, but I could slow down. There could be retardation. I could move in the negative side, but I could speed up. There could be acceleration would increase, even though that direction is negative. So let me clear this out. So then, if negative acceleration is not retardation, if negative acceleration is not retardation, then what is retardation? What is retardation? Retardation. Take a minute and think over. What is retardation? If negative acceleration is not retardation, then what is retardation? Obviously, retardation is slowing down of the object. But when does slowing down of the object take place? If I have positive acceleration and positive velocity, then this case will lead to speed up. Even if I have negative acceleration and negative velocity, this would also mean speed up. That means there is acceleration, there is no retardation. But if I have negative acceleration with positive velocity, that means there is something, acceleration is acting against the speed, acceleration is acting against the velocity. So in this case, it will retard. Even if I have positive acceleration and negative velocity, in this case also there will be retardation. Retardation. The spelling is wrong here. Retardation. What, sir? You have forgotten the spelling of retardation. Okay. I hope this concept is clear about retardation. Negative acceleration is not retardation, because negative acceleration in the same direction of velocity, which is also negative, it will speed up. Positive acceleration and velocity are positive, then it will speed up. But if velocity is acting against the acceleration, that means both are in the opposite direction. Acceleration could be positive, velocity could be in the ulta direction. Then it is called as retardation. This is called retardation. Let's go to the final aspect, final concept of acceleration. I'll clear this out. If you have noted it down, I'll clear it out. The next aspect is when velocity is constant. When velocity is constant, this is called as the uniform motion. So in this particular case, when velocity is constant and there is no change in direction, then acceleration will be zero. But if velocity is constant, in this particular case it is zero. But if velocity is constant and direction changes, then acceleration is not equal to zero. In the case when velocity is not constant, this motion is called as non-uniform motion. Not uniform motion. In this particular case, acceleration is not equal to 0. I hope this aspects of acceleration is clear enough. So let me clear it out and let us summarize what we have learned in this particular session. Summary, a quick summary. We have learned that acceleration is the rate of change of velocity. It is a vector. The formulas acceleration average is given by change in velocity by change in time. Acceleration instant is given as a small change in velocity by the small change in time. That means time is shrinking, time is tending to 0. Not 0, but tending to 0. The third aspect what we learned, the third aspect what we learned is how acceleration can be represented as a double differentiation of displacement. Acceleration can be written as double differentiation of displacement, x is displacement at dt. The next aspect what we learned, if acceleration and velocity are in the same direction, if acceleration and velocity are in the same direction, here it is negative, here it is negative, here it is positive, here it is positive, then this will lead to speed up. The next aspect what we learned was, if acceleration and velocity are against each other, if acceleration and velocity are against each other, then this will lead to retardation. Retardation. And then we studied about uniform motion. Uniform motion when velocity is constant. That time acceleration is 0, provided there is no change in direction as well. And non-uniform motion, in non-uniform motion, velocity is not constant. Hence, we can say that acceleration is also not 0. So these are all the aspects which we have learned as part of acceleration. So please like, share and subscribe and stay tuned for the next session.